We installed solar panels to escape fossil fuel pollution. Those panels are now becoming toxic waste faster than we can handle them. The materials to recycle them exist, the technology works, but here's why the clean energy solution is creating the next environmental crisis. A standard solar panel is a laminated sandwich, tempered glass front, silicon photovoltaic cells, silver contacts, aluminum frame, and in thin film panels, cadmium telluride or lead, toxic heavy metals sealed inside. Each layer designed to last 25 to 30 years fused together permanently. That lifespan matters because the solar boom started in earnest around 2000. Germany installed over 40 gigawatts by 2012. China added hundreds of gigawatts in the 2010s. Those panels are reaching end of life now. All at once, we're hitting the first major retirement wave of a technology installed globally. Recycling requires separating these fused layers. The glass must be removed, the polymer encapsulant melted or chemically dissolved, the silicon cells broken down, the silver extracted. Each step requires thermal treatment above 500 degrees Celsius. The technology that made panels durable makes them nearly impossible to take apart. And here's the economic trap. Recycling one panel costs $20 to $30 in processing. The materials recovered, mostly low-value glass, are worth roughly $3. Silver and silicon percentages are tiny. Recycling loses money on every single panel processed. Start with collection economics. Solar panels are bulky, fragile, distributed across millions of rooftops globally. Collecting them requires specialized labor and transportation. Every mile driven costs more than the materials inside. The panels are worth less than the fuel to transport them. Then add processing requirements. Recycling facilities need thermal furnaces for polymer separation, chemical baths for metal extraction, crushers for glass, clean rooms for silicon recovery. The infrastructure investment runs into tens of millions. Building capacity costs more than the entire recycled material market is worth. The material composition ensures failure. Glass comprises 70% of panel weight. Glass recycling value, roughly $30 per ton. Silicon, 10% by weight but requires extreme purity to reuse. Recycled silicon can't match virgin semiconductor-grade quality for new cells. The bulk material is worthless. The valuable materials are unrecoverable at competitive cost. And manufacturers face zero recycling incentive. Panels are designed for maximum energy output and minimum production cost. Laminated construction makes panels waterproof and durable. Modular disassembly would reduce efficiency and increase manufacturing costs. The market rewards panels that perform well, not panels that recycle easily. Germany's Energiewende, energy transition, began in 2000 with massive solar subsidies. By 2012, over 40 gigawatts installed. Those panels guaranteed 25-year lifespans. The first major wave is dying now. Germany has a total capacity under 10,000 tons annually. They subsidized installation. They forgot to subsidize disposal. China's solar manufacturing dominance collapsed panel costs from $4 per watt in 2008 to under 30 cents by 2020. Adoption exploded globally, but China built zero recycling infrastructure. Domestic waste goes to landfills. Export waste becomes someone else's problem. The country that made solar cheap made recycling impossible. Europe implemented waste electrical and electronic equipment directives, requiring solar manufacturers fund recycling. Compliance rates remain under 30%. Enforcement is weak. Penalties don't exceed recycling costs. Regulation without enforcement creates the illusion of responsibility. This pattern repeats. Wind turbine blades, unrecyclable composite materials, now piling in landfills. Lithium batteries, recycling economically unfeasible despite lithium scarcity. LED bulbs, designed with unrecoverable rare earths. Clean energy adoption creates waste crises delayed by product lifespan. Current projections show 78 million metric tons of solar panel waste by 2050. That's using conservative adoption estimates. Actual installation rates are exceeding forecasts. The waste wave will be larger, and recycling capacity remains near zero. We're building the waste crisis faster than the projections predicted. Developing nations receive older panels as aid or cheap second-hand imports. These panels have 5 to 10 years of viable life, then become waste in countries with zero disposal infrastructure. Poor nations inherit the toxic waste burden. Landfilled panels leach toxic materials. Cadmium telluride is acutely toxic and carcinogenic. Lead from solder and contacts contaminates groundwater. Selenium, chromium, antimony, all present in various panel chemistries. Every panel buried is a slow-release pollution device. Meanwhile, solar manufacturing accelerates. Global capacity additions hit record levels annually. Efficiency improvements mean replacing working panels early for better output. The 25-year lifespan shortens to 15 for economic optimization. The system built to save the environment is poisoning it on a delayed fuse. The recycling technology works. Thermal processes above 500 degrees Celsius separate the polymer layers. Chemical leaching recovers silver and silicon. Mechanical crushing reclaims glass and aluminum. Labs demonstrate 95% material recovery rates. The science is solved. Science allows full panel recycling with a repeatable process. First Solar operates a dedicated recycling facility in Ohio, processing its thin-film cadmium telluride panels, recovering 90% of materials. Veolia runs pilot programs in France. Rosy Solar in Germany recycles crystalline silicon panels at small scale. All prove technical feasibility. These facilities work, but process less than 1% of global solar waste combined. The barrier is pure economics. Virgin silicon costs less than recycled. Glass has minimal value. Transport and processing exceed material recovery revenue. Scaling requires either dramatically higher virgin material costs or massive subsidies. The technology exists but loses money at every scale without policy intervention. Design changes could help: modular frames, removable encapsulants, standardized sizes for automated processing. But manufacturers face no requirement. Until recycling is mandated and funded through deposit systems or producer responsibility laws, panels will optimize for performance and landfill. Technology allows circular solar. Economics prevent it.